Hello, welcome Algebra students. So we are going to do a few things today. You have a worksheet. It is a PDF in your notes in your Brightspace, and I'm going to talk us through that. It's going to talk about several different things, and then you'll get a chance to independent practice. I might ask you to pause this and practice throughout the period as well. So the first thing is find the greatest common factor of numbers. So we know this as GCF. And this is from a long while back. So we practiced it a little bit when you were early on in the year, but let's go ahead and do a little bit of new practice. So the factors of 6 would be 1 and 6, and then 2 and 3. You used this yesterday when you were working with just factoring trinomials. And now your 18 would be 1 and 18, 2 and 9, and 3 and 6. So our greatest common factor, the thing that they both have in common, the biggest thing that they both have in common, they all have a 1, 2, and a 3, but they also have the largest number is a 6. So your GCF would be a 6. Now, again, the more comfortable you are with your basic math facts multiplication, the easier this will be for you. So I'm going to ask you to consider pausing at this point if you feel pretty confident. This could be something the class decides to do together, and take a minute and try to find the GCF after just this one example. If you feel like, I'm not so good at this, I want some more examples, then don't pause it yet. And we'll go on to 27 and 18. So I'm going to just slide along here. In 27, I would have 1 and 27, 2 doesn't go in, 3 and 9, and then 18, I have 1 and 18, 2 and 9, and 3 and 6. And it should jump out to me that 9 is my GCF, the largest number that they both have. So you've got your 9 as your GCF. Okay, so 21 and 15, let's switch to green just because I want to. I'll have 1 and 21, and 3 and 7. And 15 is going to give me 1 and 15, and 3 and 5. You might say to yourself, why is she including the 1 and the itself? Just out of habit. So now I would circle, and I would say, well, the biggest one in this case is 3. And now your 14 and your 2, this should jump out without even having to make a list. 1 times 2 is your only set of factors. This is a prime number. And so 2 times 7. So our GCF would be 2 in this case. And then when you have 3 and 27, the same thing. 3 is a prime number, 1 and 3, so your GCF is 3. Okay, so now that you might be saying, why is that being reviewed? I know this, but now when we apply it to algebra, suddenly it becomes a little trickier. So I'm going to have all of these up. I will go in the order of A, B, C, D, E, etc. So it'll go across. So if I have 6y squared plus 18, what you're really thinking is, what is my GCF between 6 and 18? So you can be thinking ahead and you can say, well, 6 would be 1 times 6, right? I'm going to rewrite this as 1 times 6. You do not have to do this. I'm just doing it as a demo. And now your 18, I could rewrite this as 3 times 6. So when I do that, what I'm hoping pops out for you is that they both have a 6. So what I'm going to do is I'll rewrite this and I'll remove the 6 to the outside. So I'm going to circle that and I'm going to say, well, the 6 is common for both. So I'll take it and I'll put it outside. And I'll put some parentheses to let me know I moved it. And then I will look and I will say, well, what's left? A 1 and a y squared. So I would just write y squared. What's left? Just a 3. So don't forget about the plus sign, y squared plus 3. So what will happen now is if you were to distribute this, I'll show this in green and multiply again, 6 times y squared will be 6y squared. 6 times 3 would give me 18. When I distribute, it should give me what I started with. Okay, so now let's go on to B. And let's try this again. So what I'm really being asked to do is find the GCF between 18 and 27. Okay, so I look and I say, well, 27 could be 3 times 9. But I notice that I have a y squared this time, and I would remind myself that y squared is really y times y. Why am I doing that? Because I see that there is also a y in the second term. They share a y. They both have a y in them. So watch how this plays out. I know that 18 is 3 times 6, and then there's the y. So what I hope you notice here is that the largest thing that I can take out in this case would be the 3. I have 3 times 9, and then I have 3 times 6. Now, why didn't I write 2 times 9? Well, that's a good question. So that's when I say to myself, I made an error and I could have taken out something larger because I'll be left with this 9 and this 6. So what you would want to do if you make an error like I just did is you would erase that. And I'm hoping you're working in pencil. So now you could say, well, I made an error with this, so I'm going to say this will be 3 times 9, just like I had before, times y. And this will be 2 times 9 times y. Now there was nothing wrong with the error that I made. I could have gone and done another step, but it would have been an extra step. So it's worth erasing in this case. So what I have is my greatest common factor comes out, it's 9. But I also notice they share a y. They both have a y. So I'm going to take out that y. And then I will put what's left. My 3 is left, and 1y is left. My 2 is left, and that is it. When I multiply this out with the distributive property, I will do this showing you each step with the green. 9 times 3 gives me 27. Y times y is y squared. 9 times 2 gives me 18. So at this point, you might be feeling confident. You might want to try the next 3 and pause the video, and you might not be feeling confident yet. So let's presume that you're not feeling confident yet, or that you have just come back from pausing, and I would go through this next one. 21 could be 3 times 7, and my b is here. And then 15 could be 3 times 5, and my a is here. Right away, I'm going to notice that the biggest thing that they have, I should be doing this in blue because I've been using green for checking, is that 3. They do not share a variable, so all I can take out is that 3. So I will take out that 3, leaving me with 7b minus 5a. Now at this point, you might be able to check this in your head. 3 times 7 would be 21, and the b. 3 times 5 would be 15, and the a. You might need to show it. Now, for the next problem, I would have 14 is 2 times 7 times c, because that's c squared, and then 2 times c. I want you to notice a problem with this 2 times c, and you'll see it as it happens. I would take out my GCF. I notice they both have a 2, but then they also both have a c. Now notice that 2 and that c. If I take away the 2 and c, there's nothing left. So this is where it's wise to remind yourself that 2 is really 2 times 1, and put that 1 there. The reason for that is because you're going to be able to take out your 2 and your c. So you've got your 2 taken out and your c, and now look at what's left. You have a 7 and you have a c. And then at the tail end, you have that 1. It's a placeholder, so that when you multiply back through, you end up with your 14c squared and your 2c, which is what you started with. Okay, now it's important to know that this will help prepare us for better factoring of trinomials, because sometimes in a trinomial there are GCFs that can come out first. And believe it or not, sometimes people forget to do this, and then they end up having to factor something that's much harder than if they had noticed that there was a GCF first. So it's worth taking time to get really good at this skill. Now we go down here and we're going to kind of level up. We're going to go to some patterns. Sorry about that slamming door. So we're going to review our perfect squares. So you're going to make a list of your squares. We've done this a few times this year. So 1, 2, and I'm going to go up to 15. Notice I get a little smushed towards the end. So when I say make a list of your perfect squares, what I'm really saying is write the numbers 1 through 15 and then square them. So if you don't have them memorized, this is where you grab your calculator. I would imagine you have some of them memorized. Notice it's getting longer so I can fit it, and then shorter again. Okay, so those are our numbers. You may have to pause to copy those down. It might take you a bit to catch up, so feel free to ask the teacher to do that for you. Or pause it yourself if you're watching this alone. Now, why is this helpful? Remember, when I take the square root, and I'll show this in green, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, etc. So what you will usually see is these larger numbers, these perfect squares, and you'll need to recognize that they are a perfect square. It is worth memorizing these up through 20. So if you haven't done this yet, definitely take time to do that. Make yourself some flashcards, do some practice, be open to that. So next chance to practice is where you're going to see these show up. So I'm going to ask you to pause this again, and I'm going to say, please go ahead and multiply all these out. I know you can do it. Now, assuming you've used boxes or foil, I'm just going to show you how to do this. Hopefully you paused and now you're coming back. I'm going to show it kind of quickly. So we have our n squared plus 5n minus 5n minus 25. That turns into n squared minus 25. Note, 25 is a perfect square. K plus 10 squared. A lot of kids messed up with this in the fall because they just tried to square the k and square the 10. This is really k plus 10 times k plus 10. Then you have to do the same thing you did before. So you've got your k squared plus 10k plus 10k plus 100. This is k squared plus 20k plus 100. Notice 100 is a perfect square. Notice this is a plus sign. Notice this was a plus and a minus. See how there is no middle term in A, but there is a middle term in B or in C, and it's double of what that 10 is. That's just something to keep in mind. Letter B is back to having things that have a plus and a minus, and when you FOIL it, you get your 16 plus 4y minus 4y minus y squared. This is backwards, so you could actually write it as negative 1y squared plus 16 because these would cancel out. And our last one is very much like letter C. This is really 4 plus b times 4 plus b. When you multiply it out, you end up with 16 plus 4b plus 4b plus b squared. So this, I'm going to rewrite it with my highest exponent first, my second highest exponent, and then my constant last. So this is b squared plus 8b plus 16. This is what you looked at yesterday, that perfect square trinomial that you had to factor. So now we're going to talk about some different patterns, and these are not things you have to memorize. They are things you will want to be able to apply, and they're exactly what you see above. So this is simply showing you that when you have a minus sign and you have a perfect square and subtract another perfect square, you end up with your difference of perfect squares. You end up foiling it into two different signs, a minus and a positive. However, when you have that middle term, you end up with two pluses to begin with or two minuses to begin with. So you can go back up and you can look and you can see in both cases, I'll use a yellow to star, when we had a minus and a plus, a minus and a plus, notice you had no middle term in your end answer. So that would be an example of the difference of two squares, this minus or plus. Okay? However, when you had a plus in both cases, or it would also work if you had a minus, I just didn't give you an answer like that, notice that you had three terms. You had a trinomial, and it was started out as something just as a binomial form, but it ended up being a trinomial. So that would be called perfect square trinomials. They're special patterns. So we'll practice both of them as we go forward. Okay, so if we go on to this will be our perfect square trinomials. One was minus, one was plus. They both have a middle term. It's just that one is minus and one is plus. So now what from here? Very last section, this is our chance for you to try some. So you're being asked to either multiply or you're going to have to notice some patterns that happen to help you. So I hope that you can pause this, do problems 1 through 7, and then come back and check in. Before you pause it, I'm going to highlight that perhaps number 6 might give you a little bit of a struggle, and then I would remind you, using number 2 as an example, that x plus 9 squared is really x plus 9 times x plus 9. The way I'm going to do this for your time's sake is I'm not going to talk through the problems. You're going to come back from pausing and you'll see the solutions. Okay, so unpausing it, you will see I'm just going to highlight the solutions. You have your x squared minus 16. I just multiplied that out. I showed boxes. The second one, I didn't show it at all. I just multiplied it out. I did foiling in my head. The third one, I showed out the start of the foiling. I showed that you end up with two terms in the middle and you combine them. So our final answer is this. The fourth one, this would be an example where x squared minus 25 is really x minus 5 and x plus 5. It's one of your perfect square, difference of two square patterns. The next one is your perfect square pattern. It's where you have this added, and when you multiply it out, it ends up having a trinomial. This next one, this is where you should notice that you take the square root of 16 and you take the square root of 36, and then it ends up being one of our patterns. If you look carefully, I have made a mistake here. This should be a plus and one should be a minus. And then number 7, I just didn't do it yet, so this would be x minus 3, x minus 3. So you end up with x squared minus 6x plus 9. So notice that 7 and 5 are essentially identical, only one is minus and one is plus. So if you go back a page, you have taken these notes, you've done your practice. Now you're going to get an assignment where you get a chance to practice these skills in real time.